Hello, everyone, and welcome to our fifth episode of Math Past Year Papers on ZNotes Live. I'm your host, Yugan. I'm here with Devandhira, and today we will start with the A-Level Statistics 1 paper, Variant 2, from the May-June 2020 exam. On to you, Devan.
Okay, so thank you, Yugen. So as Yugen said, we'll be doing statistics one paper for the A level math papers, and we also have an update. So instead of me writing the answers on the spot, I've written all the answers already, and so I just have to explain them, so that we won't waste much time, and it'll be easier for us, and reduce mistakes. Right. So we can. So before we start, uh, at the exam, you'll be given the formula sheet. So in here, this is the formula sheet for the probability and statistics. Of course, we're gonna use it. And our best friend, the normal distribution table. We'll have to use this for sure. Right. So let's get started. First question: for n values of the variable x, it is given that the sum. This is the sigma symbol. So you can say sum of the x minus 50 is 144, and the sum of the x values is 944. Right, and we have to find the value of n. Basically, how many samples are there? So first, we can realize that since the sum is a linear operator, we can distribute them, and we'll get our first part here. Right. Now the next step is I can simplify this a bit more. When you sum 50, it's basically 50 times n. What's the reason for that, Yugen?
Because you are taking the sum 50 plus 50 plus 50 n times, so you just end up with 50n.
That's correct. So in short, we can just change the sum of 50 into just 50 times n, which is what we have here. And of course, our sigma of x, our sum of the x values, is given, which is 944. So we can just substitute that in, right? Okay. Now that we have an equation with only n, just solve for the n. We move the CR side and 144 here. 50n is 800. Then just divide 50 both sides. We'll have 16. Right? And it's that simple. Don't forget to box the answer. Next question. A total of 500 students were asked which one of 4 colleges they attended and whether they preferred soccer or hockey. The number of students in each category are shown in the following table. So this is the table right here. Find the probability that randomly chosen student is at Canton College and prefers hockey. Right. So there are 500 students in total. We just have to get the people from Canton, and they like hockey. So the people that are in Canton is in this row right here, and the people that likes hockey is in this row, correct? Where the intersects right here is 56. So only 56 people is at Canton College and prefers hockey. So the probability of getting it is just 56 divided by 500, right? Your chosen number over the total number, basically. Agree?
Yep.
Right.
And just a note to our viewers, that fraction isn't simplified. You can simplify the fraction if you want, or leave it as a decimal. All three are acceptable.
Exactly. That is correct. You may leave it like this, or you can simplify it. That's correct. Right. Next one. Letter B. Find the probability that a randomly chosen student is at Devan College, given that he prefers soccer. That college sounds like my name. Right. So we can use so you see the keyword here, right here, is given. When you're given a question with a probability question with the word given, that's conditional probability. That means we have to use the formula for our conditional probability, which is this one. So this says that the probability that the student is at Devar, I just put D there, given that the person likes soccer. I just put it as S. So how can you simplify this? By the formula, right here, this is the formula. That is basically just the probability of getting Devar and soccer divided by probability of getting soccer. Is that right, Yugen? Right. So we can find the first part here, Devar and soccer, from here. So this is Devar and this is soccer. That means the number of people that are in Devar and soccer are 120. The probability then is then 120 divided by 500, correct?
Mm.
Next one is soccer. So for soccer, it doesn't really matter which one because you just have to take the total, which is 280, and then divide by 500 again. That's the probability
Mm.
of getting soccer. Then you divide them all together. You can cancel out the 500, and you'll have 120 over 280 as your answer. Agree
Mm.
there?
Yep.
Anything you want to say?
No, no.
Okay, so let's move on. One of the students is chosen at random. Determine whether the events the student prefers hockey and the student is at Amos College or Ben College are independent. Justifying your answer. Right. So this is basically telling us to see if those two events are independent or they're dependent. Right. So first, we know that if two events are independent, let me just write it down in here. If let's say A and B are independent, that means P of A and B this intersect, so it's and basically it's the same as multiplying their probabilities separately together. Correct?
Mm.
So in our case, it's the same, but of course it's just a different context. Of course, we have the event A or B, or the event of H. The H is basically hockey, right? So first, of course we need to find out what the probability of getting A or B is. So
Pop
let's
up.
take a look here. Oh, sorry. Um, all right. So we have to find the probability of getting A or B. So how can we find that? Eugen,
A or B. So you have to just add the totals divided by 500, or add the probabilities is the same.
which is
For Amos and Ben, so it's 86 and 156.
divided by 500, right?
Oh yeah, divide by 500.
Yep. So that's what we have here for for A and B. Now for probability of getting H, of course, it's just hockey. How do you say the probability of getting hockey? So it's just the number of people in hockey divided by 500. Correct.
Mhm.
Now, what about the whole thing itself? The probability of getting A or B and hockey. This one is quite confusing. So how would you do that?
A or B and hockey, so you just add the hockey totals and divide by 500
E-
for each college. So Amos and Ben's divided by 500.
Exactly. So you have 32 plus 72 divided by 500, right?
Mm-hmm.
And that's exactly what we have here. Right. So so the thing is, if they're independent, that means if I multiply these two numbers, it has to
Mm-hmm.
equal this, right?
Mm.
But if you check your calculator, it's for sure not.
Mm.
So that's why I wrote this part here. Is that this number is not the same as when you multiply these two numbers.
Yeah.
Therefore, they're dependent.
Mm-hmm.
So uh, I saw some students can get confused here. So what they think is that this is a formula. I mean, it technically is. It technically is a formula. If only if they're independent. Now, the
Mm.
thing is, we want to check if they're independent. So we use this equation as a test instead of a formula, right? This is
Mm-hmm.
we use it as a test to see if it satisfies the equation. And that's basically it. Right. Next question. It's a stem leaf diagram. Two machines A and B produce metal rods of a certain type. The length in meters of 19 rods produced by machine A and 19 rods produced by machine B are shown in the following back-to-back stem and leaf diagram. Right. So we have the stem and leaf here, and here's the key. So we're asked to find the median and the interquartile range of machine A, just machine A. Right. So how do we find the median, Eugen?
It's just the middle value of between the start and finish of a organized set. So you'd have to go 19 rods, right? So you'd have to
Yeah, 19
find
rods.
uh the average between the ninth and 10th rod.
Are you sure it's 9 and 10?
Yeah, because 9 divided by 2 is 9.5, right? Or do you
Isn't it
just find the
19 plus
ninth
1?
rod? Oh,
To get the
right,
middle
right.
value,
Plus
it's 19
7.
plus 1 divided by 2, right?
Yeah, yeah. Okay, okay. If it's an
Yeah,
odd value, so you have to find the 10th value.
exactly. So for those of you who don't know yet, to get the middle value, let's say, so in this case we have 19. We have to have 19 plus 1, then divide by 2. That's basically 10, right?
Mm,
So basically you just have to look for the 10th value. Right. So let's do that. This is the first, then the second, third, fourth, fifth, sixth, seven, eight, nine, 10. So this is 10th
mm,
value right here, 8. And because of the key, it says that uh this is 0. Wait, how does it? Sorry. Um so the key says that 722 is basically 0.227 for A. Therefore, for our median, it's basically 0.238. Agree?
mm.
Right.
Yep.
Now we have to find the interquartile range. So how can we find that?
Ooh, so this is uh the the how do I
Upper
say it?
upper
The
quartile.
upper quartile and the lower quartile, and then it's the amount in the middle,
Exactly.
the
So
difference between
basically,
values.
it's the difference between the upper quartile and the lower quartile. Agree?
Yeah, yeah.
All right. So how can we find the upper quartile or the lower quartile? Let's say the lower quartile first.
So that would be the first five values because 19 plus 1 divided by 4. So the first five values, that would
Exactly.
be
So
mm,
that would
your
be
lowest five values.
okay.
Sorry.
So we can find the first five values. The fifth value from the lowest. So we have 1, 2, 3, 4, and 5. So our lower quartile is basically 0.1. Agree?
Mm.
Now what about for upper quartile?
And then you just count backwards and you get the lowest fifth value from the first.
Exactly. So we can count 5, but instead going from the lowest, we'll start from the highest, going down.
Mm.
Agree? All right.
Yeah.
So instead of starting here, we don't start here. Okay, we start from 4 here. So we
Mm.
start from here. 1, 2, 3, 4, and 5. So our upper quartile is just 0.245.
Mm.
Then we just have to subtract 0.245 minus 0.231. That'll be 0.014.
Mm-hmm.
All right. And don't forget to box your answers. And let's move on to the next question. All right. It is given that for machine B, the median, they're basically giving us information already. Median is 0.232, lower quartile is 0.224, and upper quartile is 0.243. Draw a box and whisker plots for A and B. Right. So right here, I've already drawn them. Don't forget to label the, which one is it, which if it's A or
Mm.
which one's B. So how do you draw a box and whiskers model, Yugan? What's the method?
So it's a very simple model to represent your data. Your first line, so you can see that Devan has drawn two lines at the very end between the boxes. Those are your minimum and maximum values. And in the box, the line starts at the lower quartile, and the middle line is the median, and the last line in that box is the upper quartile.
All right. So basically, this is the min, this is the max, this is our median, right? Median,
Mm-hmm.
upper quartile, and this is our lower quartile. Correct?
Mm-hmm.
Right.
And the whole box is supposed to represent our interquartile range.
Exactly. So don't forget also to label your axis, because if not, how are you going to draw it, right?
Mm.
So you have to label it first. It's up to you how you label it, but this is how I label it, and then you can draw the box and whiskers. So let's move on to the next question. Hence, make two comparisons between the length of the rods produced by machine A and those produced by machine B. So as you can see here, that the median of A is higher than B, correct? The
Mm-hmm.
median of A is higher than the median of B,
Mm.
right? So that means they're generally higher. They have a longer
Mm-hmm.
length. And so that's we can write that as an answer. Or you can also say the other way around, that B has a shorter length. You can say A
Mm-hmm.
has a longer length or B is a shorter length. Now the other one is that it's the IQR, the interquartile range. If you see the distance here, of course B is longer, right? B has a bigger
Mm-hmm.
interquartile range. That means B has more variation than A does. Or you can write that in the other way, that A has less variation.
Mm.
All right. So anything you want to say there? You want to add?
No, that's everything is fine.
Okay, let's move on. Trees in Radian forest are classified as tall, medium, or short, according to their height. The heights can be modeled
Mm.
by normal distribution with 40 meters and standard deviation with 12 meters. Trees with a height of less than 25 meters are classified as short. Find the probability that a randomly chosen tree is classified as short. Right. So it says standard deviation, so we just instantly use our everything we know about standard deviation. No, normal distribution. Sorry, sorry, normal distribution. Why did I say standard deviation?
It's
Okay,
okay.
right. So the way that you write oh my god, the way you write normal
The normal
distribution.
distribution.
Oh my god, normal distribution is like this. The h stands for height, though you can put anything you want. You can put x, you can put y, whatever. But h, because it represents height. The n here represents the normal distribution. 40 here represents the average, the mean, basically. And 12 square, technically it is the variance. Technically it represents the variance, but you write it as the standard deviation square so that it's easy to see what the standard deviation is.
Mm.
Agree again? Right.
Mm-hmm.
And we're asked to find the probability of getting the height less than 25, which is what I wrote here. So the first step when you do this kinds of question is always to standardize. Correct? There are so
Mm-hmm.
many kinds of normal distribution with different means and different standard deviations. And that's why we want to standardize it. Standardizing means that we all have to convert all those different normal distributions to what we know, which is
Mm.
when the mean is 0 and the standard deviation is 1, right?
Mm.
Okay, so this is the formula for standardizing. Basically, we want to find what's the z value from h, right?
Mm.
What does 25 correspond to in terms of our standard normal distribution? So we can find that using this formula. So we have the h, or the value before, which is 25, minus the mean over the standard deviation.
Mm-hmm.
Right, and we can just put that in. So 25 minus 40 over 12. You can just put that in your calculator. You get negative 1.25.
Yep.
And because it's less than, of course, you have to follow the inequality sign. But this time you convert from 25 to negative 1.25. Okay.
Mm.
So how can you find this value right here? How do you find this value?
Oh, you can use your table in the formula sheet.
Exactly. We can go to our table. It's our best friend after all, and look for negative 1.25. But all the values here are positive. There's no negative 1.25. So how can you find it?
Well, because the graph is symmetrical, your positive value would just be 1 minus the negative value.
Exactly. So let's take a look at 1.25, correct? What's the
Mm-hmm.
value for 1.25? So let's look for it here. This is 1.2. This is at the 5. So it's this value right here. Agree?
Mm-hmm.
0.8944. But remember that you have to 1 minus that. So that our answer is just 0.10156. Wait,
Yep.
0.1056, not 156. Right.
Yeah, yeah.
Let's say if you don't know whether you should 1 minus, you have no idea. Let's say you're confused. You can
Mm.
always draw the graph. Like here, I draw the graph here, and if you take a look at the region, it's this part right here, correct?
Mm-hmm.
Now the question is, does 0.8944 correspond to this region? Does it even make sense?
Yeah, yeah.
it doesn't make sense, right? Because
Yeah, it doesn't. It doesn't.
0.8944 is greater than 0.5. It cannot be that small. So we just have to
Mm-hmm.
1 minus that. Just a small trick for you.
Yeah.
Right.
Another way to visualize it is if they're asking for, like, the question says age less than 25 and 25 is less than the mean, your probability can definitely not be more than 0.5 or the other way around. You guys can like play around with that and see like how that makes sense to you.
Exactly. That's correct. Right. So next question. Okay.
Mm-hmm.
Of the trees that are classified as tall or medium, one third are tall and two-thirds are medium. Show that the probability that a randomly chosen tree is classified as tall is 0.298, correct to three decimal places. Right. So the probability of
Mm.
getting tall or medium is 0.8944. Why? Because if it's this is short, if you're gonna get medium or tall, just one minus that, we'll get this back.
Mm.
Okay. Now it says that one third are tall and two-thirds are medium. We can find the probability of tall, just divide by three of this, because it says that it's one
Mm-hmm.
third of this. Just divide by three, and we have our answer.
Yep.
Okay. Anything to add?
Nope,
You good?
that's it. That's
Okay.
easy 2 marks.
Okay. Right. So now we have to find the height above which three trees are classified as tall. So we can put that as an equation first. And now we're looking at t here. So, oh wait, sorry. Right. So basically, we, we need to find what's the value of t such that when you get the probability of z greater than that value, it's equal to 0.298. Why
Mm-hmm.
greater? The reason is that let me draw the normal distribution curve again. Remember, tall means it's a high end, right? Like if it's
Mm.
short, it would be from the middle to somewhere at the back. That means if it's tall, somewhere in the middle, into the front, right?
Mm-hmm.
That's why I write greater because the region would be, greater than this value t right here.
Mm.
All right. So, uh, but it's much easier to find less than because we can just see from the table what the value of t is, right? So we can do that. So if you want to convert this, then we have to 1 minus 0.298, which is 0.702. Agree?
Mm. Yep.
So what is the t value? So that the probability of z less than that value is 0.702. How can you find that?
You're gonna have to go back to your table and find the value
Hmm,
0.702.
exactly. So right here, you can just search the table by yourself, find 0.702. But the closest one we got is here, 0.7019. The next one
Mm.
is already greater. So we have no choice but to use that one, right?
Mm.
Right. So what does this value correspond to? That's basically zero point 0.5 and 3. Therefore, our t is just 0.53.
Mm-hmm.
Now that we know the t value, well, technically it is the z value, and we want to find the height, that means we have to reverse the standardization. Instead of going from
Mm.
h to t, we have to bring the z to h, right?
Mm-hmm.
So we can do that, but instead of putting it at h, we put it at c here. And we just have to solve it. We plug everything in, 0.53. We're looking for the h, so we just let it be. Minus 40, the mean, divide by the standard deviation. You solve it, multiply by 12 plus 40, and you have this as the answer. Is this correct,
Mm-hmm.
Egan?
Yep, that's correct.
Okay, right. Next question. That's 3 marks for you. Very easy 3 marks. They give you the whole page for that. Right. Next question. A fair three-sided spinner has sides number 1, 2, 3. A fair five-sided spinner has sides number 1, 1, 2, 2, 3.
Mm.
Both spinners are spun once. For each spinner, the number on the side on which it lands is noted. The random variable x is the larger of the two numbers if they are different, and their common value if they're the same. Show that the probability when x is 3 is 7 over 15, right? We can do this
Mm.
simply by making a table right here, right?
Mm-hmm.
And this one represents the 3-sided, this one represents the 5-sided, right? And so you just have to do it. So it says that x is the larger of the two numbers. If they're
Mm.
different, if they're the same, then take the same number. So example, we have 1 and 1 here. Of course, we'll have a 1. If we have
Mm-hmm.
2 and 1, we take the larger number, which is 2. And we do the same for everything. If it's 3 and 1, then it's 3. And so on. Right? And we have to look for the probability of getting 3. So right here, let's count the number of 3s there are. So we have 1, 2, 3, 4, 5, 6, 7. So there are
Mm.
7 3s, correct?
Yep.
And what's the total number of outcomes? It's 15, right? So
Mm-hmm.
because it's 3 times 15. So we have 7 over
3
15,
times
and this is
5,
our
not 3
answer.
times 15.
Oh my. My bad. 3 times 5. Brain too fast, sorry. Right, so 7 divided by 3 times 5. I almost said it again.
Mm.
Right, so next one. Draw up the probability distribution for x. Alright, so we have to know the possible values first, which is, of course, 1, 2, and 3 from our table. So, which is why I wrote here 1, 2, and 3. Then we have to look for the probability.
Pop up.
Oh, sorry. Right. So the probability of getting 1, that's just you just have to count the number of ones, which is
Mm-hmm.
2 divided by 15. So we have 2 over 15. For 2, it's the same way. There are 6 of them, 6 over 15. We found what 3 was, so it's just 7 over 15. That's it.
Mm.
That's your 3 marks. As simple as that. As simple as that. You get 3 marks for that. Right. So
Mm-hmm.
next question. They even give you 2 pages to the back. That's so much. Okay. Now we have to find e of x, which is the expectation of x, and the variance of x. That's the variance of x bar x. Right. So how can we find expectation of x? What's the formula for that?
That is the sum of x times the probability of x.
Exactly. So right here, back to the table. So as Eugen said, it's the sum of their x values multiplied by their probability, right? So right here, we have the x value of 1 multiplied by 2 over 15 plus
Mm.
2 times 6 over 15 plus 3 over 7 over 15. And you just have to add them up, you put it in your calculator, and find the answer. So right here, I've written it. We have 1 times 2 over 15. That's what I said before, everything. And we just have to calculate that. You just pull out your calculator, whatever. You do it in your head if you're that good. And our answer should be 7 over 3. 7 by
Yep.
3. Right. Now, what about var x? Var x is a bit more tricky. So the formula is that instead of finding e of x, we have e of x squared
Mm-hmm.
subtracted by the square of e of x.
Mm.
So how do you get e of x squared here?
So it's the same as expectation, but you have to do x squared times probability of x.
Exactly. So, wait, sorry. Okay. So instead of simply multiplying their x values, you have to square the x values first, then you multiply
Mm-hmm.
them, which is why I have a 2 square here. This used to be a 2, but because it's x squared, then it's 2 square multiplied by
Mm.
the corresponding probability, and the same thing for 3, it becomes 3 square. If it's e of x cubed instead of x squared, then you just have to cube it. That's it.
Mm.
Right. So once we did this, we have to subtract the square of e of x. And we found that before, which is 7 over 3. Just don't forget to square it.
Mm.
Put this in your calculator, whatever. You should get 22 over 45. And you can write everything again, once again at the bottom, and box your answer.
Mm-hmm.
Agree there, Eugen?
Yep. that's all fine.
Uh, you know, add something?
No,
Uh,
yeah, everything is very clear here. They're just asking you to plug something in a bunch of formulas and you get your answer already.
mm, okay, okay. So if maybe some at the exam you forgot the formula for expectation of variance x, it's okay. You can just check the formula sheet. It's right here. Except that they write differently here. This is the same as E of x squared, but yeah, it's basically the same thing. So
Mm.
they got your back. Right. Next question. Find the number of different ways in which the 10 letters of the word summertime, I shouldn't be doing summertime, can be arranged so that there is an E at the beginning and an E at the end. Right. So since there are 10 letters, let's I've written 10 slots right here. We have 10 slots. So at the first slot and the 10th slot, the E's are already taking the slot, right? So you can't play with them anymore. So how many slots do we have left, Yugen?
We have 1, 2, 3, 4, 5, 6, 7, 8, 8 slots.
So we have 8 slots left. That means uh and there are 8 letters left. So there are 8 slots left and there are 8 letters left, right?
Mm-hmm.
That means we want to put all the letters there. That there are 3 M's here. That's a repetition of letters. Because there are 3
Mm-hmm.
M's, you have to divide that by 3 factorial, which is right, what I wrote here. You divide that by 3 factorial, then you can just put that in your calculator, and you get 6720. Is it correct,
All
you can?
right. Yep, that's right.
You gonna add anything?
Uh, no.
Okay.
Also, actually,
Oh.
yeah. Let's say there's a bunch more repeated letters. Like, let's say there's 2 T's in summertime. You would also divide it by 2 factorial
Mm, that's correct.
to
So you have to.
eliminate that sort of thing.
That's correct. So you have to divide by the number of repetition of letters, right?
Mm-hmm.
Okay. Right. So next question. Find the number of different ways in which the 10 letters of the word summertime can be arranged so that the E's are not together. Yeah, we can do that.
Mm-hmm.
So first we have. So there's a trick here. It's like probability. If we want to find the number of ways that the E's are not together, we get the total possibilities, the minus
Mm-hmm.
when the E's are together, right?
Mm-hmm.
So that you get. So the result will be when they're not together.
Yep.
Is that right, Ian?
Mm-hmm.
Right. So of course, our first task is to find the total possibilities. We can do that, of course. Okay. So total possibilities. Since there are 10 letters here, that's 10 factorial, right?
Mm.
But remember that there's 3 M's and 2 E's. So you have to divide by 3 factorial multiplied by 2 factorial.
Yep.
Mm-hmm. You can just put it in calculator and you'll get this value. 302400. Now we have to find when the E's are together. So right here, I've put the 2 E's in one box. And there are 9 slots here. Why 9 slots instead of 10?
Because you group the 2 E's together into one slot.
Exactly. So instead of having 10 slots, we have 9 slots, right?
Mm-hmm.
Right. Now we can just find the number of possible ways. Since there are 9 slots, we can just that means it's 9 factorial, correct?
Mm-hmm.
But don't forget about the 3 M's again, so we have to divide by 3 factorial again, like before.
Yeah.
So we have 9 factorial divided by 3 factorial, and we'll get this 60,480. So once you get the total possibilities, and when the E's are together, you just have to subtract them, and you get your answer.
Mm-hmm.
Right. Is this the correct answer, you get?
Yep, that's the correct answer.
Okay. So then just box your answer. Don't forget about that. Next one. They even give 2 pages for this. We did it in 1 page. 4 letters are selected from the 10 letters of the word summertime. So out of the 10 letters, take 4. Find the number of different selections if the 4 letters include at least 1 M and exactly 1 E. Right?
Mm.
So that we can split this to three cases. When there's one E and only one M, one E and of
Mm-hmm.
course two M's, one E and three M's. Correct?
Mm.
So for one E, one M, the E of course has to be there and the M has to be there. So what's left? How many letters are left after that?
There's two more letters.
Two more as sorry?
There's David.
Yeah, sorry.
What did you ask?
Like since the one for the first situation,
Uh huh.
one E is already part of part of the four, and also one
Mm-hmm.
M is there. How many letters can we
Okay.
choose from?
Oh, there are two more letters, so we can choose from one, two, three, four, five, six more letters that we can
Why
choose from.
six?
Uh, because you are excluding all three M's. No, oh, sorry, that's five. You're excluding
No,
all three M's because you only want one M, and you're just counting the rest of the letters and exclude
exactly.
one
So
E
we
as
have
well.
five letters left, right?
Mm-hmm.
Right. So out of those five letters, how many do we want?
We want two
Why?
because we have one E and one M, so we have two more letters to choose to make our four-letter combination. So we need, yeah, two more letters
Yeah,
out of those five.
exactly. So that means when we choose out of those five, we have our we have to use our operation choose the C, or some people would write it like this, just the same thing. So five choose two, right? For the first one.
Mm-hmm.
For the second one, it's the same method, but this time because there's only one slot left, well, one place left. That means it's five choose
Mm-hmm.
one, right?
Mm.
And for the last one, there's only one possibility. It's basic, or you can see this as five choose zero. That's basically one,
Mm.
right? Then we just have to add all the possibilities right here, which is 16. Agree?
Mm-hmm. Yep.
Right. So next question. On any given day, the probability that Mona, not Moana, I thought it's Disney Moana, messages her Pasha is 0.72. Find the
Mm.
probability that for a random sample of 12 days, Mona messages Pasha on no more than 9 days.
Mm.
Right. So as you can see here, it's sample of 12 days, and there's a success rate of 0.72. That means we have to use the binomial, right? Binomial distribution.
Yep.
So the success right here is 0.72. And to get the failure, you just have to 1 minus the success. There's 0.18.
Mm.
Right. So this is messaging. I just put M for the random variable. Though you can put anything you want. That's up to you. So M can be represented as a binomial distribution where the success is 0.72. So the first slot is for P and the second slot is for N, which is the number of samples there are.
Mm.
Okay. Right. So we want to look for Mona messages Pasha on no more than 9 days. That's basically the probability of getting M less than or equal to 9 days. 9, right?
Mm.
So how can you do that? Of course, you can just add from 0 to 9 if you're brave enough, but that would be really tiring. So there is a more efficient way. Instead of adding from the probabilities from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, there's like that's a lot. That's a lot to work on. We
Mm-hmm.
can just do 1 minus the probability of m greater than 9. So all
Mm.
we have to look for is 10, 11, 12. Correct?
Mm-hmm.
Rem- Remember that it's greater than 9. If this is greater, less than or equal to, then the other side has to only be greater, right?
Yep.
All right. That means 9 is not included. And so we just have to look for this. Right. So how so let's do that. First we have to look when the case is 10, right?
Mm-hmm.
Right. So when it's 10, uh, so, right, I forgot to say how to find it. So for a specific probability in binomial, let's say x is equal to x here. I'll put it down here.
Mm.
That means the number of sample, choose x, right? And choose x,
Mm-hmm.
multiplied by the success, power of x, and multiplied by the failure, n minus x, correct?
Mm.
Right. So it's the same thing here, but this time because it's 10, we have 12 choose 10. We have
Mm-hmm.
12 choose 10. And the success to the power of our x, well, basically it's 10. And the failure is 12 minus 10, which is just 2.
Mm.
Right? Right. And we just do the same thing for 10, 11, and 12. We add them up, 1 minus that, and we'll have this our final answer. Is this correct?
Yep, that's
0.696.
correct.
Nice. Okay.
Also, just to add, if some of you do find this way really long, you have to write this out to get your marks. But if your calculator has something called a sum operator, it looks like a sigma, you can learn how to use it and just kind of type out the variables and take your sum from, in this case, 10 to 12. And then your calculator will just do the work for you. So you don't have to write out this lengthy thing in your calculator. This is just one way to do the calculations really quickly.
That's correct. Yeah, I also have that in my calculator, but I guess this is, I mean, it's fine. It's also fine, right?
Oh yeah, yeah, yeah. You kind of have to write this to get your marks.
Oh, okay, okay. Right. So, next question.
Yep.
Okay. So, Mona messages Pasha on 1 January. Find the probability that the next day on which she messages Pasha is 5 January. It's just 1 mark. This should be easy.
Mm.
So, on 1st January, she messages. Okay. Th- We have the next day she messages Pasha is at 5th January. That means she doesn't message him at January 2, 3, and 4, correct?
Mm-hmm.
That's why I put the X here. It means that she doesn't message. And she finally messages at January 5.
Mm.
Right. So basically, this is saying fail, 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 success. We have the fail to the power 3, and then you multiply by the success. So it's just 0.28 power 3 times 0.72, right?
Mm.
Just evaluate that, and we get our probability. That's
Yeah.
it. That's an easy one, Mark. So don't miss it. So next question. Use an approximation to find the probability that in any period of 100 days, Mona messages Pasha on fewer than 64 days. Right. You can, of course, do this manually, but that's if you're crazy. You can add
Yeah,
from
that's
0 to 64, but of course, they tell you to use an approximation, so that would be much easier. So we can approximate the binomial into the normal distribution, correct?
mm-hmm.
So, so what does a normal distribution need again? What
It
what does
needs
what do you
a
need?
standard deviation and mean.
And exactly. So that means we have to find the mean in this binomial distribution and the standard deviation.
Mm.
Okay. So first, let's put out all the information we know. We have that n is 100. That's the number of samples. The success is 0.72. Nothing has changed. And the q is 0.28. Right?
Mm.
Okay. So how do you get the mean? What's the formula to find the mean?
Mean for a binomial is just NP.
Exactly. So right here, the mean is basically just the sample multiplied by the success. That's just 100 times 0.72. That's just 72.
Mm.
Now, what about the standard deviation?
That is NPQ. You wrote it down, so I don't really have to remember.
Yeah, I know, but I mean, sure, yeah, right. So you can do NPQ. So when you do NPQ, you get 20.16. But don't forget that is still the variance. NPQ is
Mm.
the variance. So if you wanna find the standard deviation, you have to take the square root. Okay,
Mm-hmm.
right. So that means our normal distribution can be written this way, where the mean is 72 and the variance is 20.16. You can write this as a root of 20.16 squared. That's also fine, but this is also fine too. and we're asked to find the probability that m is less than 64. Right, you can.
Mm-hmm.
So how can you find this?
M is less than 64. So you can approximate this, of course, using your normal. You'd have to find your z value, your probability, and then take the values before. I mean,
Exactly.
the probability that it gives.
Yep. So don't forget that we have to standardize this first, right? Why is 64 in the standardized normal distribution? But the problem is,
54. Yeah, okay, continue.
sorry. So this is our standardization formula. Of course, you just have to put the m
Mm-hmm.
there. But the problem is, we are approximating something discrete into something continuous. Remember that binomial is a discrete distribution, while
Mm-hmm.
normal distribution is continuous. Like it's very smooth, While for binomial, it's like straight, straight, straight. Like there are
Mm.
bars there. So it's this. So there is a way to. Oh, okay. Yeah, it's okay. It's okay. So there is a way to make this more accurate. Remember that if we bring discrete into continuous, it's not gonna be that accurate. So the way to make it more accurate is that we have to apply the continuity correction. All right. So how do you apply it? So it says that the probability of m is less than 64 right here. To apply the continuity correction for this case, you have to do 64 minus 0.5, which is 63.5. Oh, where's it even going? It's okay. Let it be. Right. So once we have that, 64 minus 0.5, we have 63.5, right? Then we can finally put it in our m right here. And just put this in your calculator. You have negative 1.893. Hi, Yugan. How are you?
I'm fine. My cat just walked in.
Oh my god. Okay. Right. So basically, I was saying how we can convert by using the continuity correction here.
Right, right.
Right. So once you put this in your calculator, you'll get this. And of course, how do you find this? What's up? What's p of z less than negative 1.893? Of course, you can just go back to your table, look for negative one, look for 1.893. Sorry, 1.8, which is right here. Then 9. That means we'll have to use this one, right? This value.
Yep.
But because we have a 3 at the back, we can use this 3 to put the digit at the back there, this 3 digit.
Mm-hmm.
And the cost of adding, and the cost of adding 2, uh, correct?
Mm-hmm.
Right. So we have, what was the value before? Let me just write that. Okay, 0. So we have 0.9706. But because we have the 3 there, we have to add 2 at the back too, which is just adding 2 right here. Or in other words, you can add by 0.0002, and you'll get this.
Mm-hmm.
Right?
Yep.
All right. So once we get that, remember that this is negative value. We're looking at the left tail.
Yeah.
We have to 1 minus that, 1 minus the value that we got before, and we get our answer. Here, 1 minus this.
Mm-hmm.
All right, and the answer is just 0.0292. Is that the correct answer?
Yeah. That's our final answer.
Okay. And that's it. Anything you want to add, Egan, here?
Yeah. Just because that this question involves an approximation using another distribution, you can again check your probability using the binomial distribution. It won't be the same. It will be very similar. So that's how you can check that it's the same. Again, they're not asking you to use the binomial thing because you're going to have to do 0 until 64, which is really long, unless you know how to use the sum operator, which you can do
Exactly.
using your calculator. That's all.
Exactly. So I guess that's it. That's the end of the paper. Actually, we're amazing.
Yeah, that's the end of the paper. Do you have any final notes, Steven?
I guess that's it. Just mm, nothing much actually. I don't really have any comments to say, but this is quite fast. We did it under an hour.
Yeah, we're looking to do more episodes really quickly like this to our
Yep.
viewers, so you guys don't have to stick around so long, and we're gonna have to present it in a much nicer way too. So, yeah, that's the end for today. I hope everyone enjoyed this session and learned something valuable. And thank you for you, David, for taking your time to do this session. And good night. We'll see you soon for
Yep.
our next episode, A
Which
level
is
mechanics.
okay. Mechanics on Wednesday, right?
Mm-hmm. Next
Okay.
Wednesday. And
So
to
thank you
all
guys for
our,
watching.
oh, sorry,
Yeah.
and just to everyone celebrating, happy Deepavali.
Oh, happy Deepavali. Yep, yep. Right. So thank you. Well, we'll see you next Wednesday.